Hi, I'm SHAHARIM, and today I will explain about the theoretical of Green's theorem. So what is Green's theorem? It is a convenient way or an alternative to calculate the closed curve, which is more easier than using line integrals. If you can see here in the red box, this is the formula for Green's theorem, and this is the example of diagram where we can apply Green's theorem. So, how or when to use Green's theorem? There are two factors that we need to obey in order to use this formula. First, it only works for cases where C is a simple closed theorem. It cannot be used for an open curve. Why? Because Green's theorem reconverts line integrals to a double integrals. The double integral are taken over the region D inside the path. If we look at this diagram, the region D is inside the curved line here, the blue color region. Okay, so if it is a open curve, there will be no region D, so we cannot use Green's theorem. Next, it only can be used for vector field in 2 dimensions. It cannot be calculated for vector field in 3D, even if it is a closed path. Alright, so bear in mind, in order to use Green's theorem, make sure it is closed theorem and vector field in 2 dimensions. So to utilize the Green's theorem, there are 2 cases. One is positive and the other is negative. How we can recognize whether it is positive or negative? We can look at the diagram. So for positive, the curve will be run anti-clockwise. In anti-clockwise here. We can look the arrow here. It is in anti-clockwise. So this is the formula for positive cases. For negative cases, it is the curve run in clockwise way. Okay, so the differences between positive and negative in formula is we need to put negative sign before the double integral sign here for negative. For positive, make it like this. Okay, so that's the difference between positive and negative. So when we use this Green's theorem, make sure we know whether it is positive or negative, so we can put the sign of negative if it is a negative. So make sure to look the curve whether it runs anti-clockwise or clockwise, so we can get the right answer. Okay.
Assalamualaikum warahmatullahi wabarakatuh. My name is NAJWAN and I will do question number 1. The question is evaluate integral C of minus x square y dx plus xy square dy, where C is the positively oriented circle of radius 3 centered at the origin. Then we open the MATLAB software. Firstly we need to draw the circle to obtain the limit needed for the double integral later. To draw the circle, first we write this x equal to 0, then y equal to 0, and radius r equal to 3, because our equation is x square plus y square equal to 9. Then the theta is from 0 until 2 pi, which is a full circle. Then the a equal to r cos theta plus x, and the b equal to r sin theta plus y. Then we type plot AB, then we enter. This is the circle that we get where we can get the limit, which is r from 0 until 3 and the theta from 0 until 2 pi. Then we solve for the equation, where our equation is minus 2 square y dx plus x y square dy, where we know the dx part is the pxy and the dy part is the qxy. So we write since xy, then we write p equal to minus x square y and the q equal to xy square. Then the function that we need is the differentiate of qx minus differentiate of py, where qx is q differentiate respect to x and the p differentiate respect to y. Then we enter. This is our answer, x square plus y square. This equation we will need to use at the double integral. Then we solve for the double integral, but we need to change the equation before into the polar form, where we use r and theta, and we know x square plus y square equal to r square, and the double integral will be double integral r square r dr d theta. Then we solve for it, where our f will be r cubed. Then we do the double integral, where the limit for radius is 0 until 3 and limit for theta is 0 until 2 pi. Then we get our answer, 81 pi over 2.
Question 2 is evaluate integration x plus exponent square root y dy plus dy plus 2y plus cos x squared dx, where c is the boundary of the region parabola x equals to y square and y equals to x square. So from the question we can know that x plus exponent square root y is p and 2y plus cos x square is q, and we can solve the equation using the Green theorem. And first we need to find the graph. I use MATLAB to find the graph. So first of all we need to define the x and y variable, and then we put the range, which is -2 until 2, and then we put the y equation for the first graph. So that we plot the graph. After that I type hold on to so that I can put another graph, and I use y1 equation. After that we plot the graph x and y1. After finish we hold off, and the graph will become like this, and then we know the limits and the graph. So after we find the graph, in Green theorem both we need to differentiate and integrate. So first we need to define x and y. After that we put the p equation and then q equation. After that we can differentiate p to the x minus q to the y, and I put this place so that the answer will come out at the common window. After we got the value, so we can integrate. First of all we need to define an x and y again. After that we put the function -1, the answer from the differentiation. After that we can integrate. This is double integration, which is f to the y, which is the limit is from square root x to the x power of 2. After that we integrate x, where the limit is 0 to 1, and the answer is 1/3.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad AQEEB bin Abdul Razak and we'll solve for question 3. Question 3 is given function xyz equal to 5y power of 2z I component plus z power of 3y for j component plus xyz for k component. Find divergence and curl. Divergence in curl. Divergence are two characteristics of how flow is behaving on vector field in small neighborhood around a given point P. Divergence is a measurement of how much flow of fluid enter the neighborhood around P compared to how much it leaves. For example, this is vector field and this is point P. This is flow of fluid that coming will go out. So this is the divergence. What's going in will go out. If more fluid or flow enter than leave it, the divergence will be negative at P because the fluid is gathering at the point. If the same amount of fluid flow leave it, then divergence will be 0 at P because the amount that come in is same with the amount that leave. If more fluid or flow leave than enter, the divergence will be plus at P because the fluid is leaving the point. So this is the equation. For divergence is del dot product with F. Del is partial derivative of z I component plus partial derivative y for j component plus partial derivative z for k component, and function is function I, function for j component, and function for k component, and we dot, we get this. For curl, curl is the measurement of rotation of vector field in the neighborhood around P. So the vector field that come in will make a rotation because they are different of value. For example, for this point P will rotate to this side because this one have more value and will make the point P rotate to this side. If curl positive at the point, then fluid flow or pedal will rotate counterclockwise. If curl negative at the point, then fluid will rotate clockwise at P. If curl 0 at the point, it will be no rotation at P, irrotational. And this is the formula. Curl equal to del cross product function F IJK. So this IJK, partial derivative X, partial derivative Y, partial derivative Z, function 1, function 2, function 3, IJK. Okay. Back to the question. So we know that the formula for divergence is del dot product with F. So del F1 del for Y F2 plus del Z F3. Then we substitute the F1 with 5y power of 2z, F2 x power of 3y, and F3 x by z. And we get 0 plus x power of 3 plus xy. And the last, we get x power of 3 plus xy. So make sure for the product IJK is no IJK. So for curl, we know the formula is del cross product with f. So we put like this, ijk. This I product, this is j product, and this is k product. And we add z minus 0 because we close this and we times it and then minus this. And the final one we get xy for I component minus yz minus 5y power of 2 for j component plus 3x power of 2y minus 10yz for k component. Okay, there are other method that we can use for search divergence and curl, that is we use MATLAB. Okay, for divergence we just put the code and then we put the I component, j component and k component here, just like the question. 5y power of 2 z for I component, for j component x power of 3 y, and for the k component x, y, z. Then we click run and the answer will pop up here, x power of 3 plus y, z. Let's compare x power of 3 for x, y. Then for curl, so the code is quite similar but the difference is at here. This is I component for j component and this for k component, and we click run and we get this I component, j component and k. Okay, let's compare. Xz for I, 5y power of 2 minus xy, okay, 3y x power of 2 minus 10yz. Okay, so that's all for me. Thank you.